He is a seasoned IT professional, test automation expert, and quality assurance innovator, whose dedication to innovation and progress has earned him the reputation as a strategist in the information technology space. He was named one of 33 test automation leaders to follow in 2017 by techbeacon.com. I would add that you should be following him now if you didn't already start following him in 2017. And according to udemy.com, he is one of the top Selenium WebDriver instructors across the globe, educating 50,000 plus students on the ins and outs of test automation from 120 different countries. You can catch him on Udemy, on ultimateqa.com. I mean, your resume is quite long, Nikolay, and we've got just a small portion there, but you should all at least check out Test Automation U, because there are free courses there, and then follow him on Ultimate QA as well as on Twitter and everywhere else, because he's got tons of great content, and we're blessed to have him tonight. So welcome, Nikolay.
Cool. Yeah, thanks so much for that amazing introduction. Really appreciate it. And thank you all for having me. I'm super happy to be here. Let me jump into the presentation and hopefully share something cool with you all. If you do want to follow me, I'm on Twitter. There's my Twitter handle. And then, of course, you can go to ultimateqa.com. It's been my home base since 2013, so you can get a bunch of my blogs and courses there if you want to check those out. But most importantly, what gives me all the credentials is that I'm an animal lover. So you have to trust everything that I say. So yeah, today I want to talk to you all about how to achieve parallel test execution in automation, which I think is very important, especially in today's day and age where we want to move really fast, you know, releasing a continuous deployment kind of manner, doing all the continuous integration stuff. Paralyzation is absolutely mandatory to making that happen, to get that fast feedback loop from our CI pipelines. There are 4 mandatory requirements for parallelization. Your tests must be atomic, autonomous, you must manage test data correctly, and you have to avoid the static keyword. Technically, your tests don't need to be atomic, and that's just a little bonus, but this one is so important that I want to talk about it, because this will help us all to get automation that is much faster and more stable as well, especially in terms of UI automation. This all applies to all types of automation, unit testing, integration testing, but most of people who do unit integration testing, they already know this and they do this out of the box, but for some reason in UI automation, this doesn't get translated as well. So that's why I want to talk about this. So let me show you guys something really interesting here really quickly. So I have this suite here of 190 tests. I'm going to run it for you all here. They're all going to run in parallel, and these are all tests that follow these automation best practices and principles that I'll talk to you all about here in terms of making code paralyzed. So here I'm using Sauce Labs because I work there and I get it for free. But of course, we can do this in any environment. We can run parallelization in any environment, and all of us today have the hardware capabilities to at least run 10, 20 tests in parallel easy, even just on our little laptops. So here you see it. So I was running 70 sessions in parallel. Here I started up a build. We'll see how quickly this build finishes. Give it a moment. Let me go back to the code and talk about some of these tests that are being executed here. So these tests, what I did was, as I said, I applied automation best practices in terms of making these tests parallelizable. So what you'll see here is they all look kind of really small, very focused. And where these tests came from was actually these anti-pattern tests. There's these end-to-end tests, which I would like to further clarify and call flow tests, that are very common in the industry, which is okay, but I'm hopefully here to convince you to do better today. And these flow tests that go screen to screen and do long flows. This one does like a user flow where it logs in, does checking out. It does a bunch of other operations here, and ultimately making this test really long. So if you ran this test, across the 18 different platforms that I'm running all of these other tests against in non-parallel manner, it would execute in about 24 minutes. Okay, so that's long flow tests sequentially 24 minutes. Now, if you look back in our suite here, that's just about finishing up. I was trying to take the right amount of time. But I can show you all one that I just ran recently, which was 36 minutes ago. You can see this suite of 190 tests will take 2 minutes and 35 seconds to execute. And that's really important. And that's why parallelization is so powerful, because actually a lot more smaller tests running in parallel is way more powerful and more stable than less larger tests. And that's why we broke up those end-to-end tests. They all have the exact same coverage. There is 10 times more tests here, but they execute 12 times faster than our large suite. I didn't run the large suite here, but I promise that it runs in about 24 minutes. Okay, so with all of that said, let's talk about how to make that happen. So atomic tests means that you basically want to test one thing. You want your test to be focused on testing a single feature. How we know if we have atomic tests? Well, usually they'll have 1 or 2 assertions at most. Sometimes we need 2 assertions because maybe we will set a state of our test first, make sure that our application is in the right state before actually doing some UI validations and then validating what we want to validate. So that's how usually, and you'll also notice, if I'll show you some examples here, all of our atomic tests, they'll be really small. You can see here, they are few lines of code. That's another, it's not an indicator that it's an atomic test, but it's kind of like a green flag showing that, yeah, potentially these tests are atomic. You can see I'm opening up multiple different kinds of features here, and let me see, login feature. Here's another one. See, they're all really small, really focused atomic tests. All of them have 1 assertion. So those are atomic tests. And what I showed you before was that end-to-end test. It's non-atomic because you can see it has many assertions. So here's one, it's validating that we should be able to log in. Then it's validating that we should be able to log out, and then doing so many other things, right? Can a user check out, and so on and so forth. This end-to-end test does a lot. And the way we create atomic tests is, well, one of the ways is really simple, is you just start pulling out the functionality that you want to test into its own test. So for example, in this flow test, when we want to test whether we can log in, we just pull that out into its own test, right? So, oh, sorry, this one is, does the page actually render whenever we pull it up, right? So in this case, we just pull it out into its own test. Open up the page, assert that it's loaded, done. There's your atomic test. 1 assertion, validating that. But then, of course, one of the most popular questions that usually comes along here is, what about those end-to-end tests, or better classified as flow tests, right? What happens when we have a scenario such as where maybe we need to check out, or maybe we need a user that fills out 5 forms before they can purchase a house? How do we handle those situations? Because how can I purchase a house if I don't go through all the other steps in order to set up the state of the application? And so what that basically boils down to is having scenes and testability in our applications. Web applications are much easier to do this in. Mobile applications are drastically harder. Mobile automation in general is really hard. But in web applications, at least, we have to be able to work with our developers to create applications where we can basically control the state of the application and mock out or mimic anything that's irrelevant, and then perform the operations we do want to perform in the UI that are relevant. I'll show you all a bunch of examples of this. Here, so we have a few options for controlling the app state of our applications, right? Basically mocking out what we don't care about. so that we can focus on only what we do care about. We can use web APIs, we can use cookies, we can do JavaScript injections, and we can do database manipulations. So let's talk about, for example, using a web API. How can we create a flow scenario using a web API that allows us to create an atomic test out of that? So I got a video here I'll show you all just because I don't want things to go wrong. So this is on our favorite shopping website on Amazon. I'll show you all an example. So here right now, I'm just kind of showing you what I'm mimicking an end-to-end scenario, right? A manual test, basically, that we would want to try and automate and make atomic at the end. And so basically, we're going to Amazon. We are logging in. After we log in, we're going to search for a product. And then we're going to add the product to the cart. And then that will be our test, right? Can we add a product to a cart? That's the feature that we care about. But of course, we needed to go through all of these steps beforehand before actually testing whether we can add an item to a cart. So how can we isolate all of the other stuff which is irrelevant, like the login? If the login fails, that doesn't mean that a user can't add an item to a cart. If a user can't search for an item, that doesn't mean that a user can't add an item to a cart. And so here, I'll show you how using a web API, we can simulate it. So if you saw, what I did was just basically copied the Google URL that already has the query string parameters. So you can see, sorry, not the Google, the Amazon URL. So you can see it has a bunch of query string parameters. And right away, it already took me to this page that I searched with the right book. And so that's one web request taking me to this page. And so at this point, we could introduce our Selenium automation. It can step in, it can click the add to cart button and make sure that the number of items in the cart was updated. And so that's how, of course, I did it in Amazon. I don't work for Amazon. I don't know their API, but if we had our own applications, that's something that we could do, is use our RESTful API to perform that call, put that application in that state, and then bring in Selenium or whatever other automation framework you're using to do the UI interactions that we really care about. So there was another interesting part about that, which is how we were able to actually log in, right? Because hitting an API doesn't necessarily mean that you will be authenticated. And so, oh, I don't have an example of that, unfortunately, but I bet if I go to Amazon and don't look at my recently viewed stuff, I just got a puppy, so there's a lot of puppy-related things now. Trying to keep him busy. But if you go to Amazon, and I am already logged into Amazon, right? How does Amazon know that's who I am? Is because Amazon drops cookies in our browser. And so if we come here and we check out the cookies, you can see that Amazon has dropped cookies. And a lot of our applications usually do the same thing, especially with authentication. There's an API that we can hit. That API will give us a cookie. We can take that cookie, we can drop it in our browser, and we can be logged in within 100 milliseconds, 300 milliseconds, we can be logged in, instead of having our UI test going through actually filling out username, password, clicking the login button, and then logging in. Not only is that slow, but it can also obviously break because, let's say, invalid locators or improper synchronization, something like that. So again, that's something application specific, but most of our applications these days doing authentication can do something like this. It's just a matter of either having that subject matter expertise yourself or talking to the developers and saying, hey, I got this test. The feature I want to test is really taking me 15 seconds, but it's taking me a minute to log in. How can I bypass that? And most likely they'll say, hey, you can hit this API and you can be authenticated. And then you just add that to your automation and make your test much more stable and faster. Then there's also JavaScript stuff that we can do. Sometimes we don't have APIs available. In a lot of larger I would say legacy systems, larger banking systems, we find that because the systems are so old, a lot of them are still on mainframe, they don't have robust APIs that you can just hit, or even if they do, maybe the other systems that they connect with, like many other teams all over the company don't have the systems to work together, so sometimes it's not possible. So we can do stuff like with JavaScript. So let me show you an example here. So here I'll show you that end-to-end test that was executed, that does a lot of bad practices where it goes from screen to screen, validating many things. I'll just speed through here because it does a bunch of stuff that's not necessary for this purpose, but ultimately, let me see here. Yeah, so ultimately, the thing that it does here that we can simplify is right there it logged in. This is all doing Selenium right now, by the way. It adds an item to a cart, it fills out the checkout information stuff, and then it finishes the checkout, right? So just the checkout flow, which a checkout flow or any other end-to-end flow, it's all the same thing. It's still a bunch of screens we have to go through to put our application in the right state before we can actually validate the one thing that we really wanted to validate, which was, can a user check out with the item in the cart? And so we can actually make this test simpler by doing some work with JavaScript. And so let me show you that example right here. And so that's why this test, well, it takes 26 seconds, but it's actually much faster than that because it takes a while for the VM to boot up. And here, so here what you can see is first, we bypass all of the pages that were not relevant to the checkout scenario, and we hit the cart page directly. So here it is. We don't need to log in. We don't need to add an item to a cart. We just hit this cart page directly. Now, this is possible with this web application. It may be possible with your web application. Again, it's about exploring and figuring out what's possible. And so what you'll notice here is I just did a JavaScript injection, a JavaScript call. It dropped 2 items in the cart, and it also logged in the user. Now, with this application, it's possible because it's a dummy application, and there is no authentication. So all the authentication happens in the front end, which is really bad, and most applications can't do that. But you likely can manipulate the UI with JavaScript, such as dropping 2 items in a cart. And so now, so far, I've performed only one Selenium interaction, which was just opening the page. I performed a JavaScript command that drops 2 items in the cart and logs the user in. And at this point, we're going to have Selenium step in and actually just do the checkout process, which was ultimately what we cared about. And so this right here, you see, is just Selenium performing these operations. Let me see here. I think I have some code I can show you all for that. So here's that test. It's also, I'll share the repo with you all. It's at the end of this, but this is that test. So it should be able to check out with items. So you can see we have our checkout overview page. We open it. This is just Selenium acting right here. This is, of course, Selenium too, but it's just doing a JavaScript command, which, of course, we can do without Selenium as well, but setting the cart state. And so in there, it performs 2 JavaScript commands that do that. And then here's that one assertion, right? Arrange right here, and then act. This is act and assert actually together. So it just does a finish checkout, and then it just validates that the checkout is complete. If you all are curious about those JavaScript operations, let me see if I can get those here. I forget what the test is called. It should be with checkout items. There you go. And I actually updated that method name. It's called inject user with items now. And, oh. So here are the 2 commands. So it's simply using window and then using session storage, and then it's just dropping items into the cart. How did we figure this out? Well, I just talked to a developer and I said, hey, I don't want to be logging into the application. I don't want to be searching for stuff. How can I simply bypass all of that nonsense and make my test more efficient and more atomic? And then he said, hey, here, you can use these 2 lines of code, put them in there, and you can make that happen. And it was a 5-minute conversation. And then finally, the fourth option we have for manipulating the state of our application is database seeding. So I don't have an example, unfortunately. I always have a plan to add more examples to this just to make things more clear, because I feel like examples really help. But one theoretical example I can say is, right, a lot of us maybe work on our application and we need some kind of a user. Let's say that user is a 35-year-old female that is married with 2 kids making $50,000 a year, right? So that's all records living in a database. We could go into the database, create a user, fill out all of that information to have a female that's 35 years old and so on, and then utilize that user in our test automation, and then at the end, delete them. So that's how we could do database, making sure always to delete at the end so that we're not junking up the database with test users.